All right, we are getting to the end of our rational expressions chapter. And the last thing we need to do is be able to solve equations that have fractions with some variables in it. Okay, so our objective is to be able to solve these types of equations and discard what we call extraneous solutions. And we're going to talk about what those are as well. So here's the basic idea. If we look at a simple numerical example, quickly think to yourselves, without really doing the math, what's x? Hopefully you came up with x being 2, because 1/9 plus 2/9 is 3/9. Let me ask you a question. If I changed all of these 9s to 15s, now what would x be? Hopefully you still said 2. The bottom line is I could change x to whatever I want. I could change them all to y's. And x is still 2. Okay, so the key is, as long as the denominator is exactly the same, your equation, the rest of your equation just becomes irrelevant, and you're really only focusing on the numerators when you do the actual solve part. Okay, so basically what we have to do is figure out a way in each of these equations to get it down to just the numerators being important. Okay, so if we look at this first one, we cannot simply just say 1 plus 3x equals 1. The reason is our denominators don't match, so they're not irrelevant. That would kind of be doing this, saying, okay, 1/3 plus blank fourths is 3/5, and saying it's 2, because 1 plus 2 is 3. Well, that doesn't make any sense, right? Because we have all different denominators. There's a couple options here. I'm going to show you the first option, and that is to get a common denominator everywhere. So you need to figure out what your least common denominator is. Okay? So factor anywhere you can. We get x minus 4, x plus 4, difference of squares for that denominator. And so then our least common denominator, or least common multiple for our denominators, is x minus 4, x plus 4. So we just need to get every term, including the one on the other side, to have that denominator. So what we'll do is we'll multiply that first fraction by x minus 4 in our numerator and denominator, because that'll give it the x minus 4. It already has the x plus 4. And we're going to multiply, I'm not going to write it all out, we're going to multiply the 1 by our entire least common multiple on the top and the bottom. So then here's what we get in our next step. 1 times x minus 4 is just x minus 4. Our second fraction we did not adjust at all. And our third fraction is just our least common multiple over itself, because we multiplied 1 by that on top and bottom. Now don't start canceling things out. If you start canceling things out, you're not going to have a common denominator anymore. So where we're basically at in the problem, which I'm going to kind of show you in blue here, is we're at the point where we've got this 1/3 plus something thirds equals 5/3. It no longer matters that your denominator is 3, it just matters that they're all 3's. So what you can do at this point is say, okay, I've got a common denominator on all of them. I can now ignore my denominator and just continue solving. Okay, so I'm going to do that. On the left side, I've got x minus 4 plus 3x. That reduces to 4x minus 4. On the other side, I've got x minus 4 times x plus 4. If I multiply that all out, if I FOIL, I get x squared minus 16. My middle terms will drop out. As soon as you see quadratic, you should know that you've got a couple different ways of solving here. I'm going to erase a lot of this stuff that I've got so far so I've got more room to work with. You've got a couple ways that you can solve. You could solve by factoring. You could solve by the quadratic formula. Really, pretty much whatever you want is going to work out just fine. You could also solve with completing the square. That would work fine too. Okay, so you have some choices. The first step in pretty much all of those, though, is going to be to get everything over onto one side. So I'm going to subtract 4x and add 4 to the other side. And I get 0 equals x squared minus 4x minus 12. I can solve this in a lot of different ways. I'm going to solve it with factoring. Okay, we did that just for a couple days about a few weeks ago. So factor, and I get x minus 6 times x plus 2 equals 0. If I solve basically each of these individual equations, x minus 6 equals 0 and x plus 2 equals 0, I get x equals 6, and I get x equals negative 2. Now, you should probably go back and check to make sure your answers are right. So, if you want to, you could go ahead and go back and check to see what we have. But yeah, it's going to work out really nicely. Okay. Let's take a look at another example, and let's take a look at a different method that you can use. Another method that you can use, I'm actually going to skip ahead to, no, I'll do B. B, we could get a common denominator too. We're already almost there. The other choice that you have is to multiply. I like this option a little bit better. You can multiply by your least common multiple. Okay, so like if we were to get a common denominator be x minus 3, we can just multiply every term by x minus 3. So I'm going to multiply by that here, here, and here. It gets multiplied in the numerators, okay, because I'm multiplying by like x minus 3 over 1. Okay, so when I multiply it by the 9, I get 9x minus 27. I'm going to go ahead and distribute. When I multiply by it in this fraction, though, I'm not going to distribute. Here's what I'm going to be thinking. Now, I'm not going to actually write this, what I'm writing right now. I'm thinking, oh, I've got 6x minus 3 over x minus 3. But the x minus 3 should cancel, so all I'm going to get is just 6. So that's all I'm going to write. And the same thing happens in the first fraction too. So now I've got 2x minus 6 equals 9x minus 27. I'm going to subtract 2x from both sides and get 7x. I'm going to add 27 to both sides, and I get 21 equals 7x. And I get x equals 3. Now, go back and check this x equals 3 answer. Plug it back into the original problem, not anywhere down here. It's got to go all the way back into that original one. Plug it back in, pause, and then come back. Hopefully you noticed a problem. When we plug in 3, we get 6 over 0 minus 6 over 0 equals 9. You cannot divide by 0. That's a problem. It doesn't work. So the solution we found didn't work. The reason is we changed it. We didn't really solve it with the fractions in there. Anytime you're solving with fractions, you're kind of getting rid of the fractions at some point. But this solution looks like it works, but it really doesn't. So we actually have no solution here. This is what we call an extraneous solution. It's a solution that we found using everything in math was just kind of fine, but the problem is it didn't work with our original equation. Okay, so this is what you have to do. When you're done with these, you do really need to go back and check to make sure that your answer doesn't make your denominator into a 0. That's going to be the big way that you're going to have a problem with these. So now I've got C for you here. You can try this one on your own. You can either get a common denominator or you can multiply the denominators out of the problem. Try it in whatever way makes you feel comfortable. Pause and then come back. Okay. I'm really hoping you did that. I'm going to multiply everything by x minus 2 times x minus 4 because that's my least common multiple. Okay, when I multiply it by the negative 1, I am going to have to multiply all of that out. Okay, so when I multiply all of that out, I would get x squared, so now negative x squared. I would get minus 6x if I multiplied all this out. That's now a plus 6x because I'm distributing this negative 1. And then negative 4 times negative 2 is 8. Multiply the 8 times the negative 1. There we go. Okay, so I FOILed these out and then multiplied everything by negative 1. In the 4 fraction, if I multiply by both of those things, the x minus 4s will cancel, but the x minus 2 won't. So I'm going to distribute the 4 into the x minus 2 and get 4x minus 8. And then in the other one, I'm going to distribute the x into the x minus 4. Oops, did I do? Yeah, no, I did that right. And then I'm going to get x squared minus 4x. Okay? So combine your like terms, and I get x squared minus 8 on this side. Okay, add x squared, that's 2x squared. Subtract 6x from both sides, and add 8, and negative 8 plus 8 is 0, so that's what I get. I can actually solve this one with factoring too. We didn't really look at many examples that looked like this, but if it's uncomfortable for you, use quadratic formula. That would be fine as well. So I can do this by factoring out a 2x. Then I get x minus 3 equals 0. Set each of those individually equal to 0, and I get x equals 0 and x equals 3. If you go back and you look at your original problem, you get neither of those answers makes your denominator equal to 0. So they both should work out just fine. And as we find out, yeah, they actually both work. So both of these solutions work. We didn't have any extraneous solutions. The only time where you should have one of those extra solutions is if your denominator is equal to 0.